All right, we've got two more examples. Here's the next one. Consider a trapezoid sketched in the coordinate plane below. Two vertices of a trapezoid are located at -2. So we've got two vertices here and here of this trapezoid, and then the other two lie on this semicircle. All right, so what's happening here is that we are moving this point around. All right, so we expect this point in the first quadrant. So anywhere on this region, all right, I'm going to create some sort of triangle or trapezoid. So I'm going to go ahead and talk about a constraint here. All right, they give you this. And so what I can do is I can place it right on the I can put this point right on the y-axis, in which case my trapezoid ends up being a triangle. Right, so because of this mirror imaging on the other side, if I mirror image this point, it would stay at that point. Right, so this would be at x equals 0, which is entirely plausible, right? Or I can move this point all the way to the end, in which case you just have a, well, you have a line. Right, so you would have no area, but that's fine, right? That's perfectly possible as well. So that tells me that my domain would be 0 to 2. All right, so we are maximizing area of the trapezoid. 1/2 h b1 plus b2. So using this arbitrary looking diagram here, highlight what's going on. All right, so if x is somewhere in the middle, not necessarily the middle, somewhere between 0 and 2, we're going to have this diagram. This is B1, which is the lower base. This is B2, which is the upper base. All right. The height of the diagram is h right here. All right. And then so now, let me just flatten this out. All right. So B1 in this case would be from -2 to +2. So B1 is equal to 4. Right. The height of this diagram is the same as the variable y. And then the width would be from here to here would be x, and then mirror image on the other side from here to here would be x. So the second, the B2 value from here to here would be 2x. And then they give you a formula for y. So I'm going to plug that in. I'm also going to shrink this down because I'm running low on space. All right. So you look at the diagram, you get y is equal to square root of 4 minus x squared. Square root 4 minus x squared, 4 plus 2x. All right. So this is my instance of one variable. Here's my domain. I'm ready to find critical points. I need a derivative. All right, before I do that, I'm going to rewrite this as 4 minus x squared to the 1/2, 4 plus 2x. Right. So product and chain rule here, 1/4, 4 minus x squared to the -1/2 times -2x. Times 4 plus 2x, right? So take the derivative of the first term, leave the second term alone, plus the first term, 4 minus x squared to the 1/2 times the derivative of the second term, which is just a 2. All right, I'm going to move this domain piece so I have that space to work with. All right. Okay, so let's clean this up. So 1/4 times a -2 gives me a -1/2. Let's see, we've got 4 plus 2x multiplied by x, so that would be a 4x plus 2x squared. All right, so what I've done is I've taken care of this part times this part gives me the -1/2, and then I took this, distributed it to that, giving me that part. And then I have, whoops, then I have this 4 minus x squared to the 1/2 power. On the other side, we have 1/2 and 2, so this is just 4 minus x squared to the positive 1/2. All right, so what I'm going to do now is I'm going to take this piece, which they have in common, and I'm going to factor that part out. I'm going to do it right here. A prime, if I factor out the lowest power of this exponent, I'm going to end up with a, all right, so if I distribute this part out, this -1/2 out to this, I'm going to get a -2x plus x squared. Right, so -1/2 times all of that, minus x squared, sorry. All right, and then if I pull out 4 minus x squared to the -1/2 out of this, what I'm going to do is I'm going to just subtract the exponents. I'm going to end up with a 4 minus x to the first power. All right, let me just double check my work here. 4 minus x squared. All right, so this cleans up as the square root of 4 minus x squared in the denominator. Get a -x squared minus x squared is -2x squared. Right, and then minus 2x plus 4. Right, I'm just going to keep going, and I'm probably going to shrink this down so I have more space. If I pull out a -2, I get x squared minus x plus 2 plus x minus 2. All right, so -2, that factors as x plus 2, x minus 1. So that gives me two critical points at -2 and at positive 1. And remember that my domain was from 0 to 2. So we don't use the -1. Or sorry, we don't use the -2. Right, we're only going to use positive 1. And again, I'm going to shrink this down. Right, this is the third thing I'm looking for, which is critical points. Okay, so now remember we have a closed interval here, so I'm going to use the EVT to maximize. Right, so go back to the very beginning. My function is this right here. All right, a prime of 0 gives me 1/2 root 4 times 4. So this is 16. All right, plug a 0 in, I get a 4. Let's see. Oh yeah, so that's a 1/2, not a multiplied by 2. All right, I get a 4 when I plug a 0 in. Let me shrink this down. Undo. All right, let's see. Okay, so when I plug a 0 in, I get a 4. If I put a 1 in, this is not a prime, this is just a. A of 1 would be 1/2 root 3 times 6, which is about 5.196. So that's already bigger. And then if I put a 2 in, I'm going to get, we already kind of talked about this at the beginning, you'd get just a horizontal line. You get an area of 0. So that means that the maximum area is right here. Right, so answer our question. What is the maximum possible area? Is 6 root 3 over 2, so that's 3 root 3.